Hello everyone. If you have watched my first video about this composite panel buckling, today I want to introduce the postbuckle of this composite panel by using riks method. But first of all, I need to check the composite layouts uh, effects to the buckle load. So I copied this model from the last videos and give it a name, and in this model I will decrease the price of the composite layouts, so I don't pick up this symmetric option. Then the layout just has 8 plies and the thickness has reduced to half, and we can check it by the ply stack plot. Here we can see there is just 8 plies in the panel. I will not change the other settings and give it create a job, and solve it. It will be solved quickly, and I want to check the layouts. I want to check the effect of the plies number to the buckle load. So I check the first buckle mode here, and it's about 4.6. And if we don't decrease the price as we watched in the last videos, I can show you here. So here we can open the buckles with 16 plies, and here is the buckle load of with 8 plies. As we can see, this load has a large difference. If we have 16 plies, the buckle load is 25 kilonewtons, and if we just have 8 plies, the buckle load is about 4.6 kilonewtons. So there is a great impact on the buckle load. So this is the first thing. Then I will introduce how to do the post buckle with the riks method. So with the post buckle model, and in the last video we have introduced how to create this composite panel and the composite layouts. So in this video uh, I will not introduce it again. So let's go in a step module. Here we need to create a riks static riks method step, and I can show you how to create it. And here in the general tab, we have a static riks step and continue. So we need to open the long geometry option, and we need to give the stopping criteria. I will show you how we give this criteria. So this is the nonlinear geometry option. We take it on, and in the stopping criteria, we choose the maximum displacement, and here we give the point load of displacement with negative 0.08. It means when this load, this point, the displacement of this point reached negative 0.08 in the 3 direction, the analysis will stop. So this are all we need to set for this analysis. And here in the incrementation, we need to set the Abaqus increment and maximum number of increments. But if we don't, it also work. So it's okay. And in the output, we can give it a pre-selected default field output, and also we can create a field output with the composite layups, because we use the composite layup. And anything here we need to choose the panel layup and the field variables we need to check. And here we can specify all the plans or the plans we need to check. Now we just keep it default. So this is the field output. We can also output the point load, the displacement of the point load. This is the energy, and here we create a displacement output of the point load. Here we choose the set and the point load, and here we just need to the U3, which means in the Z direction displacement. So these are the output settings. Then the interaction module, we just as the last video says, we create a equation constraint to keep the point load has the same displacement with the entire edge. So here is the settings of the equation constraint. Then we need to give the boundary condition and the load. The boundary condition is the same as the last video we do in the buckle analysis. As we can see, the bottom edge is fixed and the top edge we give it free in the U3 degree, and the left and the right edges we give it a symmetry boundary condition and constrain the U1 and U2. So this is the boundary condition. Then we need to give it a load, which is a concentrated force in the point at the point load, and the magnitude is 10 kilometers, 10 kilonewtons, and in the negative z direction. So this is the load. And then we need to introduce the imperfection of this panel because it is a postbuckle of the composite panel. We need to use the imperfection keyword. So here we need to edit the keywords in the post buckle, and here we have created this imperfection, and we can add it after the material definition. So this length we need to edit the imperfection, and the file is the buckle file we have solved in the last video, because this can give us the buckle mode and buckle load. Actually, we need to introduce the imperfection as the fraction of the buckle displacement. So here we use the first 4 moles of buckle, and this is the fraction coefficient. Because the imperfection keyword is not supported in CE, we must add it in the edit keywords. After we add this length in the keywords, we click OK, and then mesh is as we created in the last video. It has S4R element type, and then we need to create this job and solve it. Sorry, we had deleted the buckle file, so I need to resolve it. Because this file we need the FIL file. So in the buckle we need to add a keyword here. We don't add it. We need to add a keyword in the buckle model. And here is node file. After we add this keyword, it will create a FIL file and used for the post-buckle analysis. So I resolved this buckle analysis, completed, and then I submit this one. It will not show up the warnings and complete the analysis. So completed. I'll check the results. This is the composite stress, and we can check the displacement, and we have output the displacement in the z direction of the point load here. So this is the displacement of the point load. We can save it as absolute value. Use 3. So this is the displacement. And then I want to extract the reaction force. I will in the z direction. So I need to choose all fixed node. Fixed. This is the reaction force of the fixed node, and I want to get the summation of this force. So I use the sum function and add all this to the function. Then I will save it as force and plot it. So this is the reaction force. This is the peak load. Here we can see it's a little lower than 25 kilonewtons, and we can probe it. It's about 25 kilonewtons. So the imperfection we added has not affected the results greatly. And we can combine the U and force. So this is the displacement and the force diagram. The max load, and we can check for the linear buckle load. Linear buckle. Open this. So this is 25.121 kilonewtons, and this one is about the same value, 121. So today we have introduced how to do the post-buckle analysis by using rig method, and showed how to add the imperfection keyword into the input file and solve the model and get the displacement force diagram. So this is all the content in this tutorial. If you like to learn Abaqus CE, please subscribe my channel and let's learn together.